Alright guys, so this is all about physical and chemical properties and physical and chemical changes. This comes down to how we describe matter. So the first thing we need to talk about is like a physical property. This is like the most simplistic piece we're coming into. A physical property is just really something that you can observe or you can change without changing the identity of the matter, the chemical identity of the matter, which is like what makes the matter what it is. So if we were going to look at like this football here, or really imagine that it's a real football, how do we describe it? Well, you could say that it's brown and white with a little bit of black on it. You could say that it has laces. You could say that it's kind of oval shaped. If you've ever felt the football, you could say that it has a rough texture. These are all ways in which you can describe the football without ever having to change the football. You can observe these without having to change the football into some totally new substance. So that's kind of just some examples. We can look at some other ones, like you look at the car in this picture. You can go, oh, well, it's heavy. You can assume that it's heavy because this guy looks like he's pretty strong, and he looks like he's kind of struggling to lift the back end. So say that it's heavy, it's blue, it's mainly made of metal with some plastic and some glass. It has some areas that are transparent, meaning they're clear, you can see through them. There's lots of different ways in which we can describe that. Or another one here, the ring is shiny. We would say that and so another word for shiny is lustrous. It has a lot of luster, and that's kind of going to be an important term for us this year, is that something is lustrous, meaning shiny. It would be lightweight. It would be metal. These are ways in which we can describe this substance without changing it into something entirely new. So some examples of physical properties are things like malleability and ductility. These two at the top are going to be very important for us this year. So you're going to need to really know what these two terms mean. So here's what they mean. Malleability means that something can be hammered into sheets. Really, we can kind of think of it as something that is flexible and metallic. But if you take like a big block of aluminum, you can hammer that aluminum to make thin sheets of aluminum foil. That's what it technically means to be malleable, is that it can be hammered into thin sheets. Ductility means that something can be pulled or stretched into wires. So you can take a copper rod and pull it and pull it and pull it and stretch it, and eventually end up with like this over here, which would be copper wire. So that's what those two mean. Solubility means the ability to dissolve. Density, which describes the ratio of mass to volume, the color of something, whether something is thermally or electrically conductive, meaning that it can transmit thermal energy or electrical energy, the mass of an object, shape of an object, the odor of an object, the volume or physical size of an object, physical state, like the state of matter, solid, liquid, gas, plasma. These are all ways in which we can describe the physical properties of an object. These are examples of physical properties. We also can look at ways of separating objects based upon those physical properties. So we can use a process called distillation, which really is when you evaporate the liquid away and something that was dissolved and that liquid is left behind. You do this with like salt water. And you could dissolve the water away and be left with the salt, and you could collect the water somewhere else. So you could separate those two. There's magnetism. Some things are magnetic, other things are not. You can use a device like this picture here is called a centrifuge, that you can spin and you can rapidly separate components based on their density. You could evaporate. This would be like the salt water issue, but just getting the salt if you weren't concerned about collecting the water, letting the water evaporate away and just being left with the salt behind. You could filter or sift. That's like what this guy's doing here. This is sifting to capture big pieces of matter, letting small pieces go through. Filtering is like that on a super tiny scale with very special paper that allows certain things to pass through but not other things. You could sort things just based on color or shape or things like that. These are ways in which you can separate things based upon their physical properties. Now, there's also going to be chemical properties. Chemical properties are properties of matter that you can only observe during time during which that substance is being changed into an entirely new substance with different properties. So this can be a little bit trickier. So how are chemical and physical properties different? Well, physical properties you can observe without changing the substance into a new material. Chemical properties are properties that you can only observe while the material is being turned into an entirely new substance with new physical properties. So that's kind of how we would look at separating physical and chemical properties from each other, or how we can look at them differently. So some chemical properties are things like whether something is reactive with a different substance, like it's reactive with an acid or reactive with a base, whether something can burn, meaning that's flammable, whether something explodes, calling it combustible. These are examples of chemical properties, saying something is flammable or something is combustible. Those are chemical properties. A really, really big important term that comes in here is the word reactive. So if something is reactive, then it means that it goes through a chemical reaction with something else. But it'd be reactive with something, reactive with an acid, reactive with a base, reactive with water. But that also describes chemical properties. So if you see that word reactive, that's a big indicator of a chemical property. All right, I'm going to shoot a second video that's going to be on chemical and physical changes. That's going to be a follow-up to this, so please make sure you come back and check that out as well.